So I'm going to run through this topic pretty quickly. Trunk-based development in the enterprise, its relevance and economics. Previously presented at Perforce's Merge conference in 2014, although I've updated it a little since. This is about trunk-based development, feature toggles or flags, branch abstraction and continuous integration and all that. So brief context. Trunk-based development is where everyone commits to one branch, trunk or master in the modern age. And if there's branches that are happening of any size, they're created for releases and then they're deleted after each release. You might want to do bug fixes with the same rigor on the trunk and then cherry pick those, not a systematic merge to the release branch in order to cut another release. You've probably attached CI to the trunk and another Jenkins pipeline to each of the release branches for as long as those release branches are alive. So we claim there's no merge hell with this, and as long as you live the built and never broken mantra, you're going to be okay doing this model, including some pretty hairy downstream possibilities that you maybe fear would have driven you to a multi-branch scenario in a different age. So this topic kind of overlaps with continuous integration and continuous delivery. So I view them personally as layers, with trunk-based development at the bottom, continuous integration, which we are reminded constantly is about continuously to integrate as a layer on top of that. And then on top of that is continuous delivery. When you've achieved the bottom two, you can turn the dial up and start firing releases into QA or UAT or even into production, depending on which type of company you're in. So it's been in use for quite a while. It's always been there all the way through the 90s. ClearCase popularized a multi-branch feature, long-running feature branch style of usage of source control all the way through the 2000s, but then dropped off just in time for Git and Mercurial to come to the fore and kind of take over with at least where the intelligentsia want to put their commits. There's some follow-up reading. This topic for this presentation is more about the economics, but you really want to get into branch abstraction, feature flags or toggles, continuous review, super important, and then multiple CI pipelines, one for each valuable piece of valuable release that could go into production, and possibly also one pipeline for the one that previously went into production still, even on trunk. So who does this? Google. They were doing it from 1998 all the way through to now, and they flipped source control just once from Perforce, which they finished up with in 2012, into something they've grown themselves that feels like Perforce. 25,000 developers in one trunk, otherwise known as a monorepo in the modern age. Many hundreds of separately buildable and deployable things in there, all with a uniform directory structure, a uniform build grammar, that would be Blaze, that we would know as Bazel. Key things that aren't really emphasized that perhaps will help the penny drop for you. They share code at source level, and that means that if somebody upgrades something, everyone gets the upgrade. So one commit could be fairly large if it's trying to solve it for several teams, and Blaze at least brings sanity to that because it has a directed graph build system that is provable. So you could say this commit will not break the build, even though it's something like 5,000 source files in one commit. They do lockstep upgrades of even the third-party stuff, so that will be checked into the source repo in a third-party folder. And it's important to point out that just because they're doing lockstep upgrades doesn't mean they're doing lockstep releases. People often think the two go hand in hand, but that's not true. So each application in Google or service would go into production on its own cadence. The only thing we know for sure is when it does go into production, whatever that cadence is, it's going with the latest of everything. So they also have, Google have, world-beating continuous integration and continuous review tooling. So, all of their DevOps accomplishments in this place have allowed them to move to a place where it's, versus the worst company, 2 orders more productive. Facebook, a bunch of ex-Googlers at Facebook, slightly younger company. They're on Mercurial, or they were, not quite sure now. They don't quite have a monorepo, but they have several very large trunks for different things. So, one for the main web application, one for Android and iOS clients. And there's many thousands of developers, and Facebook stand out for a number of reasons, one of which was they open source Buck, which was like Blaze, and maybe forced Google's hand. But the second reason they stand out is that they have maybe the best in industry continuous review. So they have a service level agreement that says that the CI will complete on a speculative commit, like a pull request. And the reason they have that SLA in place is because 10% of the humans that would do code review have already shown up to do code review, and it would be a waste of their time if the build was then to go on to break. So build breakage should come in inside of 10 minutes so that 90% of the developers who are intending to do a code review on a commit or sets of commits are not going to waste their time. Microsoft Office team. This is old news from a few years ago. They've merged all of the Office strands, so that would be Mac, iOS, Android, Windows, all into one monorepo. And whilst they're not quite doing one single trunk for all of those, they have a design that is trunkish in its nature, and I blogged about previously. And so they're doing code sharing at source level, and they have different release schedules for each of those things, and there's different version numbers for the binaries, and this is quite a step forward for Microsoft. And before we move on, Microsoft have also been achieving recently. So they've moved the Bing team over several years from a place where they were in a multi-branch reality to trunk-based development and all of the things that we come to assume as best practice as part of the DevOps canon these days. Then Microsoft again, and much more recently, they've moved the Windows team in this direction. So whilst they still have a lot of branches in play with the Windows monorepo, they are intending to do branch reduction. So my guess is they know full well they're going to trunk-based development at some point. Netflix and Uber have also started talking about the same things: monorepos, trunkish designs, sharing code at source level. Now, hedge bets. So these are really on options, if you like, not hedge bets, but they're on the order of releases. So let's consider a classic multi-team development cycle in one source control system. So there's a team A with feature set A, feature set B, feature set C, D, and E and F. And they have maybe a development period of time, and they have an intended go live period of time. Now you could see in this case that team C probably wrapped up its business and then reconvened as team F later on in that timeline. So there's planning and scheduling around that, traditional usages of Microsoft Project for some of these resource allocations. But either way, somebody fairly high up has an expected order of releases of these things, and they've bargained with development to understand the cost of delivering and engineering each. So this was a case for a US airline, and it was in respect of their purchase of another airline. We could say that there's a cost to unmerge in the event of something bad happening in that big timeline, like you're not ready to go for some really huge reason that's a late surprise, maybe a surprise that's typical of waterfall, but nonetheless, these surprises can happen even with the best planned teams and programs. So we would think that in a multi-branch era, we're in a place where we have to unmerge code or comment stuff out in branches, and that we're at least suspending development for the majority, if not everyone, for many weeks until we sort this mess out and get back on track. So you could be pushing out multiple releases and introducing a bunch of delivery risk, additional defects you'd never imagine could have happened as a consequence of the scrabble to get back on track. So we would say not so with trunk-based development, branch abstraction, and feature flags and toggles. So let's think again. We have these streams, these work streams, these teams concentrate on sets of functionality, A through F, and then this release is going to go out. So we'd say, here's our trunk. The big blue dots on the line at the bottom is the trunk commits. Each of the blue dots going up to a release branch is a commit to create that branch. Now in Git there's no real commit to make a branch, but there is in Subversion and Perforce and a few others. And then the little diamonds are releases going out, 1 followed by 1.1 and so on. And you can see there's an accumulation of the functionality in all of those releases, and that's the expected schedule. But what happens, right? The airline is not going to be ready, the other one, that is, the one you bought. And you're going to have to replan. So if you're in a multi-branch situation, this is a pretty bad piece of news, and it's going to require a lot of sort of compensation as to how to get back on track, a lot of pivoting and much delay. But we could say that in this particular case, we can think somewhat differently about the chore. So we have a history that we've achieved so far, we have the piece of breaking news, and we have an expectation or former expectation about what we would release. So we need to replan. So what we do know is now, and everything in the past is already out. What we know in the future is there's going to be something different. So now we can replan what release 1.3, 1.4, and 1.5 are, and now they actually are different accumulation of sets of pieces of information, sets of functionality. So 1.3 is going to go out with a slight delay, maybe not, probably with a slight delay, and it's going to be functionality A and B and C and E. So D is not going to go out in that one. And then 1.4 and 1.5, and by the time we're back to 1.5, we're back on track. So the expectation is that all the timelines have slipped a little bit, but by just moving a few chess pieces around, we're able to get back on track. So this is all driven by the feature toggles and flags. You flip some flags. They may be under source control, probably are under source control. You set up a CI pipeline that verifies that. And you have other CI pipelines for each of the permutations that's likely to happen after that, and maybe the permutation that just happened. So you have one CI pipeline for release 1.2, one for the new redefined 1.3, one for 1.4, and one for 1.5. You know, maybe you're still not feature complete on 1.4 or 1.5 yet, but that doesn't matter. You still have a CI pipeline for them because those teams, if they're concurrently active, all take the pledge not to break the builds. Recapping. With TBD, toggles, branch of abstraction and all that, you facilitate some things for the business to do. Low cost, last minute decision making. Scrapping part of a release, toggle something off. Unreleasing functionality in production, toggle something off again. Here's the biggie though, right? We just defined this. Hedging on the order of releases. So there's a shift left concept that's not new in the industry, but is being talked about more and more. To my mind, it comes from Barry Beam's 1980 work on the cost of change. So that is a curve, but this is logarithmic, so it's a straight line. And whilst there's people since who've argued about the accuracy of these figures, I think we all believe it to be a general truth. That the later you find a bug, the more expensive it becomes to fix. So what we want to do in a shift left campaign is move everything to the left. So you move things you could have caught during development back up into design of the software or the requirements gathering. You know, if it is an identifiable requirements defect, don't let it percolate downstream and be caught by the devs to be sent back. Try and fix it there. You know, and if it's fixed in requirements by the business analysts, it doesn't even have an item to say defect. It's just us working in, say, Jira for a more accurate definition of the story that you're about to do. So shifting left is an activity that's can be seen in any part of this sort of left to right diagram. You know, things that are defective in operations could be kicked back into and found earlier, typically in acceptance testing or development. So same Barry Beam diagram sitting there at the top, and if we think about that requirements, design, code, development, acceptance, and operation sort of sequence, we can actually imagine doing one of those each day. So if we're close to CD and we're fire hosing into QA or UAT, we might have this cycle going on for every piece of work. And whilst it might not be the same day that you're doing development on, analysis on, or even going into UAT out of development, the sequence is going to be short slices like this. So one piece of functionality is independently analyzed, coded, tested, and deployed. So to do that, we need to not break the builds. We possibly need to have a common code ownership model where anyone can commit to any place because they might have a need to cross a team boundary. And in order to do that, the review system should be objective. We can't have people saying, you're not on my team, I'm not accepting your commit. So although code reviews are interruptive by their nature, we'll find time in any team to actually tactically take time to review the pending code reviews so they can all be moved forwards or objectively rejected if that's needed. So we're going to need to have CI pipelines set up. We're going to need to have news dissemination, build radiators, whole team awareness about the state of the build, the trunk builds. Secondarily, whole team awareness about the state of the important release branches, if you have release branches, and not every trunk-based development team does. And then there's the continuous review mantra again. This is not an activity that happens once a month and is a bullying session for the lead developers. This is an activity that's equal, level, everyone participates in, nobody avoids it, and maybe you'll gather some numbers to make sure everyone does, and that it's objective. So DevOps / CD / trunk-based development practice breakdown. So this is some screen caps from my blog. Jez liked these enough to put them in Lean Enterprise book, Jez and Barry and Joanne. And we have maybe another logarithmic scale, so one release every 100 days on the left and 100 releases every day on the right. And whilst these companies that are represented here have probably moved around a little bit since this, and there's many more on the right-hand edge that you'd say are perfect examples of these practices, I'm just going to stick with the original diagrams. So we can see that the branching model changes depending on the release cadence. The in-house code changes, in-house code sharing changes, use of toggles, changes that take a while, that's where branch bar abstraction figures. And you can do feature flags and toggles without branch bar abstraction, or you can do branch bar abstraction without feature flags and toggles, but they're two sides of the same coin reasonably. Continuous integration varies depending on your release cadence. Again, manual QA, QA automation, they vary depending on your enthusiasm for CD, per developer environments, non-live shared environments. These are costly for organizations to set up, and obviously the best teams are doing infrastructure as code these days, but many teams aren't, and they're paranoid about the time taken and the cost and effort and risk of setup of another QA environment. So they kind of stick with their reduced number of QA environments and take timeshare through them, or have folklore concerning QA1 versus QA2, i.e. comments like, don't use QA1, it's got rubbish code in it. Make sure you do your testing in QA2. Things like that. And if we can move to infrastructure as code, and we can have single-click creation of new environments, including DNS records, then you're living the dream. Code review, continuous review is the best practice, but in some companies there's none, or it's sporadic, and can be cause of much angst for the people that will be dragged into code review sessions. Database changes are important, rollbacks, roll forwards, the way the changes are handled, Delta scripts. There's a Promoter's book is pretty cool on some of this, and that's at least 10 years old, but still super relevant. Talent leads your organization if you're on the one release every 100 days. So you maybe have got a whole bunch of people who say we can't get there. And the truly talented people have gone to other places where everything about their technologies they're choosing and the way they develop is much more accomplished than your typical enterprise. More controversial, application configuration. Should it be co-located with the application source? Should it be outside of all management? Or should it be configured somewhere else? Zookeeper, etcd, console. Checklists. So if you're going to try and get there, we didn't mention it before, but you should try and live and love the invest principle from Agile. Make your stories small, can do more of them in a week. You can get your iteration sizes down to a week or abandon iterations altogether. With your behemoth stories, you're risking your release cadences because you've sucked 2 or 3 developers into something that seems to be a sinking ship of a commit that can't be finished. Branch bar abstraction allows you to implement longer to achieve changes over a timeline that doesn't jeopardize your ability to go live, but is otherwise co-located with all the other code that is going to go live. Multiple CI pipelines, we mentioned that. Continuous code review, very important. Common code ownership, try and live it. You might have permissions on write, but you should at least have no permissions on read for anything other than the super algorithmically critical pieces of your system, and even then you should have doppelgangers that everyone can stay busy with. Google had some crypto around their cookie, and they had a ROT13 version for us consultants. And then you have to live the mantra, don't break the builds. So maybe not for this session, maybe a whole topic for another day. If you want to get fast builds, and you kind of need to, if you need to be able to be on it for keeping the build green, you need to perhaps factor in service virtualization tactically on some of the shifted left items within your pipeline. And that doesn't mean say that you're not going to go and test against real environments. You are, but they're going to be on the right-hand edge because they're more expensive, and you'd rather fail faster if you're going to fail at all. So your mock services, your virtualized services should be highly representative and maybe independently tested as for being consistent with the real implementations of the same thing. Maybe every team that's making a thing that could be reused by another team should make their own virtualization and ship it with their technology. TCKs, Technology Compatibility Kits. So there's a site, trunkbaseddevelopments.com. I put this together with friends this year, 2017. And it's very comprehensive, but it's not a moment in time. It's going to continue to grow, hopefully with diagrams, because that's always powerful. And that's it.